Hey team, I'm Mike, this is the Code Dojo, and I kid you not, yesterday I went bowling with a bunch of software engineers. Now, as you might imagine, after a couple of beers, the conversation inevitably turned towards how do you write the algorithm that scores a bowling game? Now, of course, I knew how to do this because I know my katas. You see, many moons ago, Uncle Bob gifted to the world the Bowling Game Kata. I love this kata because developers are notorious for over-engineering the problem. It's actually understandable. Bowling seems pretty complicated, what with all the frames and throws and gutter balls and spares and strikes, and there's that thing with the last frame where like if you have a spare then but Uncle Bob showed us that if you write your tests and you let the tests guide your design, you can arrive at a small, simple, elegant solution that works. So let's work this problem together. But first, let's review the rules of bowling. A bowling game is split into 10 frames. Each frame contains 2 rolls. Your score for any given frame is the sum of the number of pins you knock down with each of those rolls. So for example, if you knock down 2 pins with your first roll and 3 more with your second, your score for that frame would be a 5. Now, there are 2 special situations. One, if you knock down all 10 pins with 2 balls. So, for example, if your first throw knocked down 5 and your second throw knocked down another 5. This is called a spare. Spares are scored by taking 10, the 10 pins that you knocked down, and adding the number of pins you knock down with your very next throw. So, for example, a game where you knock down 5, 5, and then 3 would be scored as a 13 for the first frame. The other special situation occurs when you knock down all 10 pins with your first throw in a frame. That's called a strike. Strikes are scored as 10 plus the number of pins you knock down with the next 2 throws. So for example, imagine that you got a strike followed by a 3 and another 3. Your score for the first frame would be 10 plus 3 plus 3, or 16. In the 10th frame, it is possible to get a spare or a strike. In that case, in order to figure out what the score for the 10th frame is, you need to throw additional balls. If you got a spare in the 10th frame, you need to throw 1 additional time in order to complete the spare. If you got a strike in the 10th frame, you need to throw 2 more times in order to calculate the score for that strike. That's really all you need to know to proceed, so why don't we dive in? So let's get this first test going. And in the first test, all I want to do is make sure that I can instantiate a new game object. So can make game. And to do that, all I'm going to do is just call the game constructor. Now, there is no class called game, so the first thing we got to do here is actually create it. Like so. And that's it for that test. Next test. Okay, so we can create a game. We also need to be able to roll a ball. So let's say can roll ball. And for that, what I'm going to do is create a new game and call game.roll, and I'm going to pass in a 0, which is the number of pins that we knocked down with that roll. So that method obviously doesn't exist. Let's create it. Void is correct. Integer, that's correct. Let's give this a more descriptive name. I'm going to call it pins down. Okay. Next test. Oh, well, actually, before the next test, let's do a little bit of refactoring. These tests are kind of redundant at this point. The first test creates a new game, but the second test also does that. So the second test really covers what the first test used to be all about. So we no longer need this first test. We'll just remove it. Now we can move on to the next test. So the next thing I want to do is think about what is going to be the easiest game to score. And the answer is a game where you roll all gutter balls, right? So can score gutter game. So I'm going to imagine that there's a method called game.score, and it returns to me the score of the game. The score of a gutter game is going to be 0. Okay, so the compiler is telling me there is no game object. So let's go ahead and create that. And I know that I need to roll a bunch of gutter balls. So that's a gutter ball. I could, write this 20 times, but that would be an awful lot of duplication. So instead, what I'm going to do is use a for loop and just iterate from 0 to 20. And put this in here, and that gives me 20 gutter balls. And the score of that game should be 0. Great. Now there is no score method. Let's create the score method. It needs to return an integer. And it can't return null, so let's change this to -1 for a second, because I do want to see that test fail, which it does, so that's good. And now I can change it to a hard-coded 0, which makes the test pass. Okay, we kind of had the same situation again that we had before now in the test, which this new test has kind of made the first test obsolete, so we can now remove that before we move on to the next test. Okay, in the next test, we want to score a slightly more difficult game, but nothing fancy. Let's not do any spares or strikes or anything like that. Let's just roll all ones. Can score a game of ones. Ones. All right. So actually, the implementation of this is going to look pretty much identical to the implementation of the first one. The only difference is instead of rolling zeros, we want to roll ones, and the score should be a 20, not a 0, like that. Now, obviously, that fails. And the reason is because we're returning a hard-coded 0. So this can no longer be hard-coded. It needs to be some kind of variable, which I'm going to call score. How are we going to calculate that score, though? Well, the simplest way that I can think to calculate the score is going to be to, with each roll, keep a running tally. So you knock down 1 the first time, and say, okay, well, the tally is 1. And then you knock down your second roll, you knock down 1. We say, okay, well, now the total's 2, and 3, and 4, and so forth. So we need to remember the score across rolls. So let's put the score up here. Let's make that private. And then with each roll, let's add the number of pins that were knocked down to the score, and then we'll return the score, and that passes the test. Okay, but now we've got a bunch of duplication in our tests. Like I said, these tests are almost identical, so let's try to remove some of that duplication. The first piece of duplication is the creation of the game object twice. So let's pull that out to a place where both tests can use it. Now this will work, but it actually only works by coincidence. This is not good practice in unit testing to share instances across our tests. So we would rather have each game get its own instance without duplicating the line of code that actually creates that instance. And one way we can do that is with a setup method like so, where we will instantiate the new game in here, but declare it out there, and there. We've removed that bit of duplication. And every test now has its own instance of game, which is what we want. Okay, the other thing that's duplicated here is the for loop. The only differences are the number of pins we knock down, and for now, the number of times that we want to roll this number is the same between the tests, but we can imagine that that's going to change very shortly. Sometimes we're going to want to roll different numbers other than 20. So let me pull this out, and I'm going to call this times, the number of times that we roll something. And this I'm going to keep as pins down, like so. Let's move this up there. Okay, now that we've pulled those two variables out, this is parametric, so we can make it a new method. And I'm just going to call this roll as well. And let's actually put this down at the bottom, keep our tests together, like so. All right, so now that we've pulled out the method, I can go back and inline these. And you can see kind of why I chose these this order to this method. It now says, roll 20 zeros, or at least that's how I would read it. So now we can replace this for loop with something very similar where we say roll 20 ones. And that is much cleaner, removes a lot of duplication. It's good enough for now. Let's move on to the new test. All right, so let's do something a little bit more complicated. And the next most complicated thing I can think of is rolling a spare. So let's say can score spare followed by, now remember with a spare, it's going, the way to score a spare is it's going to be 10 for that frame plus the next roll. So say the next roll is a 3, then the score for that frame would be a 13, not a 10. So can score spare followed by, let's use that number 3. Okay, so again, game.score, and the total score for that game, so let's say you roll a spare and then a 3 and then nothing but gutter balls after that. Okay, so the total score for that game is going to be 13 for the first frame, 3 for the second frame, for a total of 16. All right, so now let's make that happen. Game.roll of 5, game.roll of 5, that adds up to 10, so that's your spare. Game.roll of 3, and then we need to roll a bunch of zeros. In fact, we need to roll 17 zeros. Like that. Okay, that's pretty ugly, but that's all right. Let's get it working. Okay, well, we've got a problem here. Our code is not really set up to deal with this situation. And the problem is that in order to properly score a spare, we need to remember that a spare happened in the last frame. And right now, we don't have any memory. We're only keeping track of the total score. So we have no way of kind of looking back in time and seeing what happened in the past. So this solution is no longer going to work. So we need a different paradigm. So instead of this idea of keeping a running tally, let's instead remember all of the rolls, right? Every throw. We'll remember how many pins were knocked down, and then only calculate the score at the end after we have all of the information. Because if we have all the information stored, we can look, back in time at the previous frame to be able to figure out if things like spares happen. Okay, so instead of keeping a running tally, we're going to need some kind of array, and we got to move the actual calculation of the score down into when score is called. So I'm going to just move all of this stuff down here, and so we don't need private anymore. Okay, let's just let that be for a second while we add in the rest of what we need. So I'm going to use an array to store the rolls, and I'm going to need some kind of counter to keep track of where in that array I am. So let's start with the counter. Private, and I'm going to just call the counter roll, which roll are you on? So that needs to start at 0. And then we're going to need an int array. I'm going to call that rolls, and that needs to be a new int array of size 21. 21 is the most rolls that you could have in a game, and that would happen if you had no strikes and then got a spare in the 10th frame. That would be 21 throws total, and that's the most that you could have. So so the size of the array should be 21. Okay, so now it's pretty easy to do this part. When a throw comes in, we're just going to want to store that at roll, like so. But we also need to increment roll after storing it, so we'll put a plus plus there, and that should remember all of the players' rolls. Okay, so now we need to fix up this calculation. So we'll start the score at 0, that's right, and then we're going to need to iterate over that array. So right to length, yep, that looks good. And we'll do the addition in here, and pins down is rolls at I, like so. That looks good. Okay. So we still have a problem though, and that problem is that spares aren't just two consecutive throws that add up to 10. They have to be consecutive within a frame, right? So you can't roll, for instance, a 0, a 5, and a 5 and call that a spare because it splits across two frames. You need a 5 and a 5 in the same frame. So we don't really have any concept of frame boundaries right now. So we're going to have to introduce that, and that's going to make things a little bit more complicated, but it's not too bad. So instead of iterating over the rolls, let's iterate over frames. There are always 10 frames. So I'm going to just rename I here frame. So we start at frame 0 and iterate to 10, increasing the frame each time. Okay, but now we can no longer use the frame iterator as our cursor for the array because we're only going to have 10 and there are more than 10 rolls. So we actually need to have a separate counter to keep track of where we are in the rolls array. Cursor, like so. And we're going to need to increment that, like that. Okay. Now, in each frame, we need to actually add two rolls, right? There's the two rolls in each frame, and our score needs to be incremented by the sum of those two. So instead of just this, we need something more like this. And since we've consumed two rolls, we don't want to just increase the cursor by 1. We want to increase the cursor by 2. Okay, so all of this has been refactoring that has not changed the behavior of this code. Right now, all the tests that used to pass still pass, and the new test, the test for spares, still fails. So let's finally fix that spare. And to do that, we're going to need a conditional that is going to test whether or not a spare happened. So let's take this and stick it in the else part, right? And this part is going to be a spare. So how do we know that there's a spare? Well, a spare happened if rolls at cursor plus rolls at cursor plus 1 is 10. Right? So there are two rolls in the frame, and the first one is at rolls at cursor. The second one is rolls at cursor plus 1, which we already know because if in our original calculation there in the else, that's what we did to get the total for a frame. So that's a spare. Now, what happens to our running total if there is a spare? The score should increase by 10, right? Because we've already established that the score for this frame is a 10, plus the first throw of the next frame, which is rolls at cursor plus 2. Okay, and we do need to increment the cursor by 2. Pass. Our spare test now works. Okay, let's do a little refactoring. The first thing is this is not clear at all. Let's replace it with a method called isSpare. That looks great. Now, let's come over here to our tests. Okay, so here's the thing with the tests. I really don't like this. I know a lot of developers that just leaves it like this, but I've got several problems. First of all, it loses the symmetry with the other tests. We had a nice symmetry going on here where the tests had the same format and the numbers just changed, which I really liked, and we've lost that symmetry. The second thing is that we've got two different levels of abstraction happening here. The one is when we're calling game directly, so we're calling game.roll, and the other is when we have this helper method that wraps a call to game.roll. And in general, I really don't, I like kind of sticking to just one level of abstraction per method. So I don't really like that either. Now, I have a solution to this. and it involves adding code to the production side. And a lot of people might disagree with this, but for me, I find that if the test code needs something, it's almost certain that some other bit of production code is going to need it. It's very rare that a test is so unique that it needs to do something that production code doesn't need to do. So for me, I find it to be perfectly acceptable to add things to the production code to help the tests out, to make the tests clean. So this is what I'm going to do. Well, actually, let's write what we'd like it to look like. What I'd really like this to look like is I'd like to call roll just one time, but I would like to pass in all of the scores. So in this case, it was a 5 and a 5, and then a 3 and a 0, and then a 0 and a 0 for the remaining frames. So wait, that's 4, 5, 6, 7, 8, 9, 10. There. I really like the way this looks. I like it because it looks like a bowling game scoreboard. Like if you were actually there at the lane and you looked up at the scoreboard next to your name, there would be a series of integers in boxes by twos. And so what I've done here is I've kind of invoked that image by having a straight list of numbers, and every two I've put a space to kind of show the frame distinctions, where one frame ends and the next one begins. So I like the readability of this a lot. It also gives me the ability to restore this symmetry, because now for game of ones I can do this 10 times, and for for the gutter game I can do this 10 times. Okay, now obviously this method was not set up to do that, so we're going to have to fix it. We'll do that by doing something like this, or actually, no, I'm going to call this rolls. And now our for loop needs to iterate through rolls.length and call roll at, or actually a better way to do this would be to use this, and we'll call it pins down. There. Oh, I missed a semicolon up here. Okay, that's fixed. Okay, cool. So tests are back to passing, but I'm still not done here because I still have this two different levels of abstraction that I talked about that I'd like to fix. And the way I'm going to fix that is I'm going to take this and I'm going to move it to the production code side. I'm going to make it public. Get rid of some extra braces there. I don't like braces. And then we can reference it like so. And now the tests are going to call game.roll. There. Tests are all back to passing. So much cleaner, so much more readable. The production code now has another useful method added to it. All around, I think this is a big improvement. Let's move on to the next test. What is the next test? Okay, well, the next test is going to be to deal with strikes. So let's score a strike. And now to score a strike, we're going to need two more throws after the strike. So why don't we throw 2 3s? So followed by 3, then 3. So what should that score be? If you threw a strike, a 3 and a 3, and then nothing but gutter balls. Well, the strike is worth 10 plus the next 2 throws, which are 6. So the first frame would be 16. The second frame is 6 for a total of 22. And then all gutter balls, so the total score for the game would be 22. Okay, now let's make that happen. It's nice and easy to make happen with our new method. We just need to throw a 10 in the first frame and a 3 and a 3 followed by a bunch of gutter balls. All right, that fails obviously because we don't have any code to handle strikes. Let's add it. And I'm going to do it, I should say, by just following the same kind of pattern that we have going here already. So let's test for strikes, and then otherwise test for spares, and otherwise just do your standard calculation for the score of a frame. Okay, so how do we tell if a strike happened? It's actually even easier than telling if a spare happened. If the first ball in a frame, which is rolls at cursor, is 10, then you have a strike. Okay, how do we score a strike? Well, we take the running total and we add 10 plus the next two balls, which are rolls at cursor plus 1, right? It is plus 1, not plus 2, because remember, the first frame only had one throw. So cursor plus 1 and rolls at cursor plus 2. And now here's the one little trick here. Remember, the strike only consumed one roll. The frame only had one roll in it. So we don't need to increment the cursor by 2 this time. We only need to increment it by 1. And there we have another pass. Okay, a little bit of refactoring. Let's clean this up so it's symmetrical with our spare code. And now we've got that. All right, next test. Let's try to do a perfect game. Let's do all strikes, right? I mean, that's the most complicated scoring, I think. So why don't we do that? Can score perfect game. What is the score for a perfect game? I think most people know that a perfect game is 300. It's just kind of one of those things that everybody seems to know off the top of their head. But you could do the math if you went through and followed the rules for a strike, right? The first frame would be a 10 if it was followed by two more. The next two throws would be strikes also, so they're worth 10 each. So that means the score for the first frame would be a 30. There are 10 frames, so that leaves you with 300. So if you did throw all 10s, how many balls would you end up throwing? Well, you have the 10 frames and one throw each, so that's 10. And then on your final frame, you would need to throw 2 more in order to figure out what the score for that strike was, for a total of 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hopefully I can count it right there. So we'll save that and run the tests, and what do you know? They pass. Our existing code already handles a perfect game. And the reason is because we're done. That's it. That's the algorithm for scoring a bowling game. As I said, a lot of people over-engineer this. It's really just, 15 to 20 lines of code at its core. And just a handful of tests will lead you to this solution. It's really pretty impressive. This kata is just a classic. Uncle Bob's been doing it at conferences and other various talks for years. And with good reason. It's pretty cool. There's a lot of good stuff in here to practice. If for no other reason, Uncle Bob likes it. And that's good enough for me. So learn it, practice it, master it. Again, I'm Mike. This is the Code Dojo. And I hope I see you again for another kata soon.